Okay, so the first thing we do is we clone this repo to our computer by taking this link here, going into R, starting a new project. We use version control, git, and then it asks for the link, and it asks for the directory where we want to save it. I have this one prepared. It's the same one I used yesterday. And then we just create it, and it should work all right. Cloning into day2 data management, and then my name. Stuff happens. And then the new project opens. All right, and now we have our new project down here. We can open the individual tasks, which is what we'll do later, or we can open the lecture tasks. So if the setup we did yesterday worked for you, then this will work for you too, hopefully, and be very easy to pull off. And today we'll learn a couple of new things and a couple of important stuff. One is what packages are and how to install them. One is how to manage and manipulate data in R, and do basic statistics, I think. Or I think basic statistical metrics. And we start with the libraries. Libraries, you can see down here, we have a tab called packages. And then we have a list of user libraries, and you see this is a very, very big list. There are a lot of libraries available. Libraries are to use a very inadequate comparison, maybe like plugins in QGIS. It's additional functions created by users, by R users. So you can write your own functions in R. You can do it in any programming language. It's the basic thing you can do in programming language. You can define your own functions. And if you created a lot of functions, like 10 or 20 or whatever you need, you can wrap them up in a package. And then you have a set of functions that you can share with other people. And accordingly, there are a lot of packages or libraries, whatever you want to call them. In R, they're often called packages. In other programming languages, they're called libraries. It's very interchangeable. You can access, and each of these packages, each of them gives you access to different functions that are exclusive to this package, and you need to have them installed and activated to use these functions. And these libraries you can very easily install, and you have to install them just one time, then they are installed. And after that, you have to activate them, and you do this by using two functions. The first is called install packages, and then the name of the package as a string, so inside of these quotation marks. And the one you need to use to activate the package is library, and then the name of the library, this time not in quotation marks. And usually you do this in the very beginning of your script. So if you're writing a script and you're coding some stuff, you always put this first, because the functions you are using are dependencies on the library, so they won't work if the library isn't activated. So that's why you put it in the very beginning of your script. And that's why it's also in the very beginning of this script here. Yeah, this is the packages tab. You can get a bit of an overview here, but I don't really use it. But it tells you which version you have installed, and you can activate it over here, but I never use it. I only use the functions. Today, or the first thing we want to do is, if you remember, here in the repo, we have one image, an image file, and we want to have this image in R and look at it in R. And to do that, we will need a package called PNG. And inside of this package called PNG are functions to deal with PNG files, which is very self-explanatory. Okay, so first we need to install this package. And we do it by using install packages. And then this has to be in quotation marks because it's a string, it's a name, PNG. And then we run this line and it says install packages. And then it says a lot of stuff and it tries to install this package. All right, package PNG successfully unpacked and MD5 sums checked, which means it was successful. Now we have this installed. Now we don't have to run the install command anymore if we want to use this package, unless you want to update it. You can also update it using this command. But now we still have to activate it. And we do this by calling library and then PNG. And then it's no longer a string, so you don't have to use quotation marks in the library command. All right, and that's it. Now we have this package installed and activated. Yeah, now we want the PNG file that's within our project. Okay, so we have this image file in our folder, datatypes.png, and we want this as in our environment, or we want it plotted. So we need to get it into R somehow. And the way we do this is we use the read PNG function, which is inside of, it's part of this package PNG. And let's define a variable called, also this image called data types PNG. Yeah, let's just leave it like this. And then we call read PNG, and then we need to give the file path in quotation marks. And this is a bit of an annoying process in R, at least if you have Windows, because you will need to copy the file path manually. We need to maneuver manually to where you have saved your stuff. In my case, it's data, and then under G, it's GitHub repos, and then this one. And here we have our image. And now we need to copy this file path somehow. And I think the way to do it is you click up here, and then there's copy address as text. This, I don't really know how it's called in English, but it's if you right click on the file path up here. Copy address as text, or copy file path or something like this as text. And now it's on your copy thing. And now you control V it into R. And now we have one big issue, which is super annoying. And that is that Windows, if you try to copy a file path, does these backslashes to separate the files, like the folders. But R reads it only if you use forward slashes, so the other way around. So you have to manually replace the backslashes with forward slashes. I know that's a bit not so great. First, I finish this up by giving the name is data types PNG. So this should work just fine. And if you have a lot of links, which we try to avoid, or a lot of file paths, which we try to avoid by using relative file paths, which is what John just said, you can press Control F this here. Okay, it's already says here, Control F, which opens a search bar, and then you can find like the backslashes and put in here forward slashes, and then you can replace, if you click on all, it will replace all backslashes in your script with forward slashes. So that's a way to do it a bit faster. But right now we do this, and then we see something shows up here in our global environment, a large array with a lot of elements. These are the pixels, and which is very large in size. I mean, for data. And now we could plot it, for example. But there's another way to do this, and that's what John asked, and I think it's also the better way to do it. and that is to use relative file paths instead of giving the absolute file paths every time you load something in. And in R, you do this by setting a working directory. And the working directory is basically the folder R searches for stuff in. It's the folder R assumes is the folder you are working in the entire time. And so you don't have, if you set this folder as working directory, the day 2 data management, Jon Terschan, we wouldn't have to specify this entire section. We only would have to specify the name of the image, which is much, much shorter and much more convenient. So the way to handle this is, of course, another function, which is called setWD, which stands for set working directory. And then there's also a function called getWD, which tells you which working directory your R is using right now. So we will do this first just to see. And you can see right now, because we already cloned this into a project, R is already using this folder we are in as a working directory, which is very, very good because now we don't need to set it. But I will still do it just to show you. We just copy this part of the file path. Like this. And you run it. And then you see nothing has changed because it's the same file path. But if you don't have the working directory already in this folder, this would have changed to this folder we gave it now. And this means we could basically get rid of this entire part. We only need the data types part because it already knows we're inside of this directory. We're working inside of this directory. So if we delete this variable and call it in again, just using this section of the file path, it will work just fine. Yeah, keep in mind that it only works for stuff that's inside of your working directory. So this only works for these files here and not for everything outside of the working directory. Yeah, that's a really good way to approach working with data in R. You should use this working directory to your advantage. Okay. Now we have this image here in our global environment. We can open it using a function called grid raster. Here it looks a bit different, like the functions we used before. It has these, what's the symbol called in English? Can somebody tell me? The double dots. It has 2 double dots in between. And these 2 double dots, they denominate the library the function you're using is from. So this function is from a library called grid, which is part of the base R installation. So that's why we didn't install it with install packages first. And the reason we use this is that the function grid raster exists several times. There are multiple functions with the same name. And so R knows which one of the 2 or 3 functions we're using. We clarify where it's from using these double dots. So you will sometimes see this in front of functions that are from libraries. So don't be confused by it. Or I could maybe, to illustrate, if I try to use help on grid raster. Wow, it's not even, okay. Maybe I just talked a lot of nonsense. Maybe we can use it without the double dots. Let's just try that. Could not find function grid raster. Okay, so we do it with the double dots. Let's go. Okay, so we use this function grid raster on our variable data types, and it opened here in the plots window, it opened our image. We can make it a bit bigger. So this is our image, and it's also kind of worthwhile talking about. These are different data types in R. We already got to know one of them yesterday, which was a vector or a list. I think we had both. But basically R has 5 different data types, and all of the data you are using, or most of the data you will be using, will be formatted in one of these 5 data types. And the first one is vector, which is just a list. It's like 1, 2, 3, 5, 6, 7, just a list. All of these elements have the same data mode. So if you remember, yesterday we've learned data can have different modes: characters, numeric, and Boolean or logical. So all of these, the same color means they have to have the same data mode. So all of these are either character, 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 or numeric, 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 or logical, 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 but not logical, character, logical, or something like that. So a vector is basically a list of data with one data mode. A matrix is, it's a matrix. It has columns and rows, but every data, like all the data inside of a matrix, has one mode only. It's the same thing with a vector, for example. So this has to be character, 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 or numeric, 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 numeric. So there's no, it's not very diverse. The array is basically the same as a matrix, but 3-dimensional. Looks a bit like a Rubik's Cube in this picture. The data frame is basically the same as a matrix, but the difference between the data frame and the matrix is a data frame can have multiple data modes in it. So this is a matrix that can have, for example, in this row, numerics, so numbers. In this row, characters, so words. And in this row, logical, which means true or false. And then we have a list. A list is basically the same as a vector, but every element inside of the list can be another data type. So you can have a list, and the list on the first element in the list is a vector, the second element is an array, the third element is a data frame, and so on. This will become more clear later, and like as we work with data. The most powerful, I would say, data type is the data frame, just because we can use different modes in it. It's also the one you will encounter the most often, I think. And then there's also more data types that are exclusive to libraries. For example, if we work with spatial data, we will have stuff like spatial polygons data frame, which is basically a data frame, but it has like a spatial reference behind it. But this is not super important. But I think this figure here is very important, just to understand what we can do with data. Yesterday we already created one vector. Using the sequence command, we created a variable called sequence 070 sequence, and it was something like this, I think. Let's do it like this. From to, oops, by 17. This one is an array. If you look at this picture, it's basically a row of data, and 0, 7, 14, 21, 28, 35, 42, and so on. And now we get to know the second thing in this picture, the matrix, which is basically the same as any matrix and everywhere. It's a very well-defined term, I would say. But we now start to create a matrix, and you can do this manually. If you load data into R, you can also like convert it into a matrix, but for now we will do it manually. So the first thing we do here is just to create a matrix. And the function to create a matrix is matrix. The function is called matrix. I will use the help function so we can see, oh, that's the typo, sorry, to see how it works. So it opens the help function with the function called matrix, is for matrices. Matrix creates a matrix from the given set of values. And then we have different arguments inside of this function with data, which is, yeah, you can give it the data, you can give it a vector or something else, so it can build this matrix on that, but we don't use it. We only use nrow and ncol for now, because we just want the basic, a really basic matrix that's not based on anything except our own stuff. How do we call it? Let's call it matrix. Now, maybe not matrix. What's a good name for matrix? Let's call it matrix. It's not, I don't know if it works because it's also a function name, but yeah. Let's give it the name 3 rows, 1 9. So it's a bit more descriptive, maybe, I don't know. And we do this by giving it matrix. So first off, you give the data range. That should be 1 to 9. I think it's either like this, or we learned yesterday, you can also express a sequence like this with a double dot. So we do it like this here. There's no functional difference between using a comma and a double dot, I think. And then we give our number of rows. That's what nrow stands for, number of rows, which is 3. And then we give ncol, which is the same thing, but for columns, 3. And then we have another argument called byrow, which is logical. So it's a true false argument. And if you give it false, the matrix is filled by columns. So it will go and fill the matrix with the values 1 to 9 by column. And if you give true, it will fill them by row. So it will go 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we give it false, which we will do, though it doesn't even matter because we just need a matrix to work with, it will fill them in the following way. You will see now. If I call this one, you will see it down here. So if we give byrow equals false, then it will do 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we give byrow equals true, yeah, you don't have to write true every time. You can also write T or F. But yeah, you can also write true or false, whatever you prefer. And if we give true, it fills it by row. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I hope this is like the syntax for this is understandable. We give the data we want to have inside of the matrix. We give the numbers of numbers of rows and the number of columns, and then we give if we want to have it filled by row or by column. I think there are not a lot of cases in which you create matrices by yourself. Usually you work with data that you have gathered in the field or like prepared in Excel or somewhere else. This one is a syntax error. Yeah, but now we have our matrix. Let's keep it like this. And now we want to index a value within this. And we already learned how to index values yesterday using these square brackets, if you remember. But now it's a bit more, not complicated, but now we have an additional dimension to it because we have rows and columns. And yesterday we only tried to index stuff out of the sequence, which only has 1 dimension. It goes from left to right. So if you remember, yesterday we did something like this: sequence 070. And then the third, yeah, let's take the second value from this, which is 7. And now we want to do the same, but for the matrix. So it's very similar in the syntax. And we want the value in the first row and the first column. So it's 1, 1. And then it gives you the value in the first row and the first column, which is 1. These little rows and columns here, they kind of already show you how to index this. So if you wanted the entire first row, you could get rid of the second one and have it like 1 column. And then you index it and you get the entire first row. If you do 2, you get the second row, 2, 5, 2, 5, 8. And conversely, you can also call an entire row column, sorry, by reversing this. That is not correct. Interesting. This shouldn't be like this. It's not 1, 2, 3, the first column. Oh, it is. Sorry, I'm dumb. I forgot that we ordered it this way. Yeah, it's definitely the first column, 1, 2, 3. Yeah, I'm not doing it for everything, but third column is 7, 8, 9. So the way you index is a matrix is you have a row and a column, and the row comes first and the columns come second. So if you want a value out of the second row, third column, it looks like this. Should be relatively clear. This I already answered prematurely. Call the entire second column would be this one. Call the entire third row would be this one. Whoopsie daisy, like this. Okay, I hope this is clear. It's basically the same as in sequence, just that we have a second dimension. You can also do the same as we already did yesterday. You can change values inside of the matrix by using these indices. So if we want to change the second row, second column value to 10, then we can just do it like this. It's like assigning a variable, so it's not different. And again, I keep forgetting that that this is the name. And now if we call our matrix, you will see that this value has been changed to 10. Another thing that's maybe relatively important is we can add more rows and columns at once. And I think this works like this, using rbind or cbind, and rbind is for rows, that's why it's R, and cbind is for columns. So if we want to add an entire row, it will look something like this, and then we have to define, I think, which column, which matrix we want to add to, which is matrix 319, and then I think you'd use this function that we used yesterday, combine, just to combine values. And now we need to give it the same amount of values that it has in the rows. So our rows have 3 values, and if we now give, I think, 4 values, then the rbind function will not work. So we have to give it 3 values. So let's say 11, 111, and 12. And if we do like this and check our matrix, you will see there's a 4th row, and it contains the values we gave it. Conversely, you can also use cbind to do the exact same thing, but for columns. Let's maybe do something different. Now I have to give 4 values because our table got longer because we added a row. So don't be confused by that. And if we check our matrix again, it will look like this. So these are very basic and easy ways to manipulate manipulate a matrix. And then next on our little data types image, we have the data frame array. We don't use today. I think we don't do anything with arrays because they are not super important, but sometimes you will have arrays and we'll find out how to work with them at some point, I think, even later in the course. But now we concentrate and like focus our attention on data frames, because data frames are very, very important and very flexible, and you use them a lot if you work in R. As we said before, data frames are basically the same as a matrix. It's a kind of table, so it has rows and columns, but each column or row can contain different modes of data, not types, sorry. There we go. Each column can contain different modes of data. And you can easily convert data into data frame format if you have something like a matrix. We have one, we have the matrix 319. We can convert it to a data frame using the as data frame command. So if we want to convert it into data frame, let's call it data frame 319. We can use as data frame matrix 319. And then you will see up here, now we have a data frame with 4 observations of 4 variables, which basically means nothing has changed in it. So it still looks like this. It will look exactly the same, or almost exactly the same. Now the columns and rows have like different designations, but it doesn't really matter. The data inside of it is the same. They are still, all of these numbers are still numbers. They are still numeric. So nothing has changed really, except that we could now maybe add a row with characters, for example. So now we could add a row saying using names or something like this. One function I didn't highlight before, but in RStudio you can, if you have something like a matrix or something like a data frame in your environment, you will have this little matrix or table symbol. And if you click on it, it will open the table in a separate window, which is maybe sometimes more convenient to look at data sets, because you can use a little filter here and like filter them for ascending and descending digits. Yeah, just so you know, this is not super important, but it's just something maybe you should know. Now we create a new data frame and kind of drop this idea of using the matrix as a data frame, just to highlight that we can use different modes. The command to create a data frame is called data frame. It's always like this. It's most functions have a very descriptive name. But the command, the function to build the data frame is called the data frame. And you basically just give the data you want to give. It works like this. I just run it for now. This data frame is called df, which is not great. I would rename it. It's from an earlier version of the script, but let's keep it for now because I don't want to change. I'm not sure if we work with it anymore later. Yeah, let's keep it for now. And this data frame looks like this. It has three rows and 2 columns, and the rows contain like a name of a person and this age. So alter is age and name is name. So we have Peter, who's 18, with Paul, who's 19, and Mary with 2R, who is 20. This is what we just defined here. We gave it 2 columns. One is called name and contains Peter, Paul, and Mary, and one is called alter or age. I'll rename that to age, which contains the numbers 18, 19, and 21. We could also add more if we need to. For example, if we add Ken and then give him an age. I'm not really sure how old you are, Ken. 24, 25? something like that. So you see, we have added one person called Ken, age 25, and this one, the name column is a character. It's strings. You can see here by the little quotation marks, and the age column is numeric. It's just numbers. So you can see, just like here, the different colors. We use different data modes inside of one data frame. It's very much possible. You can also go ahead, and that's what I talked about before, and just load, if you have any data which is in a tabular form, like a comma separated values file, a CSV, an Excel file or something like this, you can read it into R as a data frame using the function read CSV and then the file paths. Again, we don't really need the entire file path here because we have our working directory, if you remember. Our working directory is still here, and the file I want is this one, the Bürgermeisterwahl.Bonn, which is in the same folder. So we can just get rid of this. Read CSV requires an additional argument, which is the separator and comma separated values, which is what CSV stands for. That's usually a comma, but you really need to give in the correct separator here. So if your table in Excel, for example, is separated by a semicolon or like a double dot or something like this, you really need to take this into account and like put it in here. Because the read CSV function can read files that aren't CSV. The name is a bit misleading, but you have to give it the correct separator. In our case, Bürgermeisterwahl.Bonn uses the comma separator, so it should be fine. So we read this file into a variable called election Bonn. I get rid of this. And now we have it. It's up here, election Bonn. 33 observations of 15 variables. We can open this table. And here you can see what's inside of this CSV file. And we can briefly go over it. I think it's maybe not bad because the column names are in German, which is not great, but sorry. I realized far too late and then I didn't have time to change it anymore. The first one is, so these are election results for the like city council and mayor elections in Bonn. And the first column are district numbers. So in Bonn, we have 43 voting districts. The second column are the names. So we have Bonn Zentrum, Bonn Castell, whatever, Friesdorf, a lot of different like voting districts. Then we have Wahlberechtigte, which are people who are eligible to vote, so like voters. So inside of this district, Bonn Zentrum, we have 7,772 people who could vote theoretically. Then we have Wähler, which is just voters. So out of this 7,772 people, 4,680 voted. Briefwähler means mail ballot, like people who used mail ballot. This means votes that weren't counted because, I don't know, something was wrong with the ballot. These are eligible votes. And then we have the election results for different parties. We have conservatives, social democrats, Greens, liberals, left, and then BBB, which is like a local populist thing. And then we have this party. I don't know what it's for, what it stands for, and what it does. And we have the satire party. All right, so this is what's inside of the CSV file. And now we have a couple of different options on what to do with the CSV file. And first we start with a couple of basic stuff that you usually do if you load something into R, just to get a sense of the dimensions of the data and like how it looks and how it behaves. And one function we can use is the length, which just gives you the length of the data frame, which is the amount of columns, I think. Yes. So you can also, you don't need to use length for that. You can also read it here in the global environment. It says 33 observations of 15 variables. So you already know there's 15 columns. But if you want to know it through the console, you can use length. Then we have dim. Dim stands for dimensions. This gives you feedback on how many rows you have and how many columns. One information we already have, we know it has 15 columns, this table, this data frame. And we know it has 33 rows. I don't know why it says 4 rows and 3 columns here. It's that's bullshit. So these are the dimensions of our data frame. Then we can check the number of rows and number of columns. This will already look familiar to you if you remember when we created the matrix up here. We used the same arguments, but you can also check the number of rows and number of columns individually. As I said, it's a bit redundant because in the global environment, it already says 33 observations, and observations are the rows, and 15 variables, and variables are the columns. So it's a bit redundant. It's just general information. Then we have str, which is data frame structure. This as an overview over the structure of the data frame. It shows you how to reference individual columns. You can use it with the $sign, which we will use later. So it will become a bit more clear later, maybe. So you can reference individual columns of this data frame using a $sign. And then it also tells you what kind of data is within the individual columns. So here it almost exclusively says int. Int stands for integer. An integer is basically a whole number. So something like 7,772 is an integer, as opposed to, for example, a number with a decimal, like a decimal number. So we know we mostly have integers in here. We have a factor in here, which is kind of like a mixed thing. In this specific case, it's mostly characters because it's names. Yeah, it's names and like numbers together. It's a factor. And then we have one that's probably more important than these, which is summary. This gives you a very brief statistical summary on the data inside of your data frame. And it always gives you the minimum value, the first, I think, quantile, the median value, the mean value at the third quantile, and the maximum value for each column. So if we go to, I don't know, a party like the Conservative Party, we can find out the minimum votes they got in any district are 763 votes, and the maximum is 2,069 votes, and the mean is like 1,448 votes. So this is super helpful, I think. Summary is like a very good start to do statistics with. You just usually use it in the start before you start doing like proper analysis. So it's maybe good to remember the summary function. And then we also have the same thing that we have with the matrix, that we want to index values out of this data frame. And here it works a bit, a little bit different. And we left at the entire indexing question, which works somewhat similar to indexing a sequence or a matrix, which we already done before. It works similar with the square brackets, but there's also a couple of data frame specific options that you should know. But if we want to select the entire second column or have the entire second column as a data frame, we can just use the square brackets as we know it already. And then it will create, which is what we call the subset. It basically creates a data frame out of the second column. So if we write this into a variable called district name, or maybe we check it here, we get a whole new data frame, which is a subset of the old one, but only with the second column. And the difference, and that's also the difference between using two square brackets. If you use two square brackets, you only get the values inside of this column, but not the entire column as a data frame. So if we use this, we just get what's basically a list of values inside of the second column. So if we maybe write this into a variable, we can check the difference. Now you can see here it doesn't show up on the data because it's no longer a data frame. It's just a list of stuff. And if we call it here, it looks like this. Okay. And then there's a thing that's exclusive to data frames. We can reference individual columns using this $sign and then the name of the column. So we have a column called Gebietname, which is district name. And we can reference this column using a $sign. So if we run this, it will just give us the same thing all over again. So maybe I write this into a data, into variable 2. And then you can see here, it's completely identical with this approach. There's no difference. The only difference there is that you can use autocomplete in the name, which is maybe a bit more convenient, depending on how good you know your data frame. And then another way to do this is like this, which is similar to the matrix approach. We just reference no row and the second column with a comma in between, or like this. Doesn't really matter. And it gives you the same thing again. Conversely, you can also select an entire first row, which is this one, or you can use, can select one value in the first row and the second column, which is this one. All right, and now we come to a bit more interesting stuff maybe. We can, of course, calculate stuff using the data in our data frames, which is important. So one thing that might be interesting for this whole election jazz is the voter turnout, which is a percentage how many people voted. And you can calculate this relatively easy because we have a row here that's called eligible voters and then actual voters. So we know how many people theoretically could have voted and we know how many people have voted. So we can calculate a variable using very simple maths. Let me think a bit. It's just 1 divided by the others, right? And then I think, and then multiplied by 100. No, it's just it's just voters divided by eligible voters, I think. Let's do it like this. So we want to divide Geo.Bonn, and then we use this approach here. And you can see here in the autofill, these are all the columns that we have in our table. That's why I used the $sign, but You could also use this with the double square bracket, for example. And we want to divide eligible voters by eligible voters, which is basically just here's a division sign, right? And then by Wahlberechtigte, which means eligible voters. And then if we run this, we get a list called voter turnout. And inside of this list, there is the voter turnout as percentage. Maybe we can do it like this, put some brackets around this, or parentheses, or however you call them, and multiply them with 100, so we have like actual percentage values instead of these decimals. So now we have a list with 33 characters, one for each election district. And you can see the voter turnout, how many people voted in these election districts. Yeah. And you could also just add this to our original table, because it would be nice to have, right? It's additional information. Let's just add it to the table. And we do this by defining, just referencing a new column that doesn't exist yet, but it will be created. It's very easy. And we call this the voter turnout. So this is not a column that exists, but we just pretend it does. And then into this column, we assign our list voter turnout. And now, if we look into our election thing, we have a new column called voter turnout. And here are the correct voter turnout values for every district. And I think that's pretty cool. And then we could also maybe calculate the election results for one specific party. In this case, we just took the conservatives. There's no political bias here. It's just one random thing we picked. You can do it for any party you like. You don't have to take the conservatives. And the way this works is you calculate the amounts of votes the CDU, the conservatives got. You divide it by the amounts of eligible votes, I think. I think that's correct. I'm like.
Yes, I think so too.
Okay.
So it should be correct.
So it should be like this. Election.Bonn. And then we take the column CDU. And divide it by the column gültige Stimmen, which means approved ballots, or like eligible ballots. And then we maybe 100 this again, so we get percentages. And then we look at the result. And now we see the election result for the Conservative Party per district. And again, we can just add this to our data frame and like extend it like this. Maybe with a big capital letters. CDU results. And then we write our CDU result into it. And then if we go back to our data frame, we can see here at the very right, we have a new column called conservative results in percentage, which is maybe much better to read than these absolute numbers. And you can do this for any party. You can calculate anything you want out of this data frame. Yeah, this one I already rushed ahead and did this one, but if you want to add a new column, it's very easy. You just pretend you're referencing this column using the $, and then you write whatever you want into this column. You might encounter some problems, like if whatever you take doesn't have the same length as the data frame, so it does have less rows, for example. So if we want to write something that only doesn't have 33 values in it, but only 20, it will only fill in the first 20 values, and then you get like an ace not available for the other 13. So keep in mind that it just fills it from top to bottom if you do it like this. So maybe I copy this over here, and then we do it like this. So it's a bit.
We have one question regarding to change the column name in the chat. If it's possible to change the column names without changing the CSV file.
Yes, you can change the column names freely using the same thing, I think. This is a function, right? Names.
Yes, I think it should be just in the base R function.
Yes. So we have a function called names. Let's just check what it does. So it gives you the names for the columns. All right. So I see where this is going. And then we reference with the index thing, the names of our election thing, where they are equal. And this is the equal sign. So this has to be exactly the same. This is what this double equal sign means. And then we give the name of the column we want to rename, which is, let's get rid of this stuff here, CDU percentage. And then we assign this column a new name called CDU. I don't think we have the CDU percentage. Do we have it? No.
Yeah, just write, I don't know, write CDU and then percentage sign or something, or I don't know, whatever.
I just take the normal CDU column. It doesn't matter, it's just a matter of which column you want to rename. And then we do it like this, which is much easier, you're right. And then if we go into our data frame and look at the column CDU, it's renamed. So basically what happened here is we used a function. I can use a help function on it, a function called names. I kind of forgot that this existed, but it's definitely a thing. We call the functions called names, which calls which gives out the column names pretty much. And then we indexed the one column where the name of the column was CDU, and then we assigned this column the new name CDU, but in lowercase letters. So that's one easy way to do it. Yeah.
Yes, and the other way, or thing you ask to delete a column out of the box, I would think of subset function, where you can basically overwrite the data frame, but you can select the columns you want to keep.
Yes, but I think we leave it for now because we do it later in the.
All right. Yes.
I think we do subsetting. I'm not entirely sure, but we can go back to it if we don't have it. Yeah. Okay, but thanks for the question. It was really good. I forgot this function existed, but it's a thing. Thank you. So I added it here. Maybe you add it to your script, just so you remember it in case you ever need it. Adding a new row requires creating a new data frame with identical columns. Yeah, that's a bit annoying. It's easier to add a column to a data frame than it is to add a row. So if we add a column, I just showed it here, we can just reference this column and like add stuff to it. And it's not really complicated, it doesn't cause any issues. But if we want to add a row, it's a bit more complicated. We need a data frame that has the same columns, and the new data frame, then you can add using the rbind function, which we already used up here. So we're not going to do this again on the data frame for once, because I didn't prepare a data frame with the same columns. And then we also did this rbind up here. So it works the same way, but you need a data frame that has the same amount of columns, and the columns need to have the same name, because data frames have column names and row names, and matrices don't have that in R. Okay, but this is just so you know, if you want to add a row, it's a bit more annoying, and you use rbind to add a data frame that has the same amount of columns, and the columns need to have the same name. Simple statistics. Does it say here? I completely forgot what we are doing. Yeah, this is basically, we used the summary function before to show a couple of statistical metrics like mean, median, max, and so on. You can also do this on yourself if you don't want all of them. If you use the function max, you will get the maximum value of a column. In this case, we use max on the column election Bonn Grüne, which is the Greens. So we get the max voter amounts of voter so for the Greens in any election district. If we want to find out which district it has, like where is the max, if we want to find out where the max is, we can use a function called which with the same syntax. It's something like this, which, and then the arguments are in our data frame, the column Greens has to be the max of the same column. And then we find out in which row this value is hidden. And if we look at the rows, like the output is 3, so it's row 3. And if we look at row 3, it's this district called Innere Nordstadt, Inner North City. So we now know where the Greens had their highest voter turnout. It's not, I don't know why it's called simple statistics here. It's just one thing. Yeah, and if you want to find that out, oops, without looking into the table and like counting down the rows or something, you can do it like this by referencing the column and then referencing the name of the third row. So this is just an index, right? So this is just a combination of stuff we learned before. And then you get the district. Okay. And now we come to the subsetting stuff, which is what Ken talked about before. And also what we kind of did already here when we, if you remember here in this part, when we created this district name, one column, like version of our data frame without anything else in it. This is obviously not very helpful. It's just a bunch of names. But subsetting is really, it's something that you do really frequently. It can be used to omit columns that you don't use or don't intend to use in your thing, to like prune your data set to make it a bit smaller and easier to handle. And subsetting data frames is, yeah, it's quite easy. You can do it in different ways. There's different ways to approach this. And one, or the most common, is it the most common? Yeah, but it's pretty common. But one way to approach this is by index. It works exactly the same way as before. This time we want to delete a column. That's exactly what I was trying to do before when I was trying to approach the question with the renaming stuff. If we want to delete a column, we just reference this column like in an index, but we put a minus in front, and then it will be deleted. So here in this case, we will delete the first column. The first column is the district number. So if we run this, we will get a variable called Election.Bonn1, which is a data frame, which is exactly the same data frame, except one column is missing. And that's the first one we just deleted out. So using the same approach, you could also, if you want to rename a row, you can also duplicate it and delete the last row. Then probably more convenient than deleting it over the index number, because here in this, using the index number, you always need to know which position your column is in. So if you have a data frame with a lot of columns, you might not know that this column, for example, is like the 23rd column or something. So if you need a way to, an easier or more convenient way to delete it, you can do it by name, which is using the subset function. That's exactly what Ken talked about before. You can subset using the subset function. I open the documentation for subset. So subset requires as arguments an object that you want to subset, which is your data frame, Election.Bonn. And then you kind of select what you want the subset to be based on. And in our case, we want to delete the column BBB, which stands for Bürgerbund Bonn, which is this one local populist party here. And if we want to delete that, we put the minus in front. Then we use the combine. Actually, I don't know if we need the combine, but I will leave it for now and run this. And then if we check our column Election.Bonn2, we will see the BBB is gone. It's gone. It's no longer part of our data frame. Then you can also do the same as you did with the column, but with a row. In this case, we delete the third row out of the data frame. Which is, actually, I don't know what the third row is. Third row is, it's Innere Nordstadt, okay. So if we open this here, you can see the third row is gone. There's no longer a third district number, and the third district is missing, and everything, the entire row is missing. And then one other way to delete a row using a value, or like what's inside of a value, is this one. Right now, I didn't write this syntax, and I'm not entirely sure how it works. So we won't get into it in detail, but you should be able to just adapt it to whatever you want to delete. It's basically the same syntax as here, but it's a bit different. And I'm not entirely sure how this like percentage in percentage works right now. But if we use this, we will delete, yeah, sorry, I forgot to say, yeah, it deletes the 10th, the Poppelsdorf district and Innere Nordstadt, so deleted. It's not entirely the same, yeah. In this case, it deleted the third one and the 10th one, which should be here. You're correct, thank you. And then the last thing we do in this part is we learn how to deal with missing values. Missing values are kind of a blight for everyone who wants to do anything with data. There's always missing values, especially in very large tables. This one, we are lucky that it's very complete, as it should, because it's an election. It's based on election results. Would be a bit worrying if this would be incomplete. So we have to add a missing value to demonstrate what we can do about them, or what we can do, how we can work with missing values. So we just write a missing value, which are expressed as NA, which stands for not available, in R, into, whoops, oh my God, I accidentally clicked a lot of stuff and installed. Oh, I think I just ran the entire script, whoopsie. Doesn't matter though, it doesn't matter. So here we deleted one row out of the column BBB, the third row. If we go into this table, there we go. There we have our little NA sitting right there. And now if we try to calculate a mean out of this column using the mean function, we will get an NA because it can't do it. There's one NA in there. So this is a super frequent issue that you try to calculate something and then the function by default doesn't isn't like working with NAs. So it doesn't know what to do with NAs and then everything just becomes NA. It's a very common thing. You can omit the NAs from calculation using an argument called NARM, and most or a lot of functions have this argument in a different form. It's not always called NARM, but in the mean function it is, and I think in like the other a lot of statistical functions it is. And then it kind of just ignores this one NA value. And if we run it like this with the argument NARM set to true, we get our mean as we are supposed to have it. Then sometimes you need to find NAs or like subset everything out of that doesn't have NAs. So one function to find NAs is the function called isNA. If we run this, we will get kind of a list, and it shows you in which rows you have NAs. So you know which rows are problematic for your analysis and which you need to deal with. And you can also incorporate this into other functions to like replace NAs with values, or to fill NAs, or like to delete them. That's very possible with this isNA function. And then we also have complete cases, which basically shows all rows without NAs. So it's kind of a reverse version of isNA. It's basically the same thing, but now it's true instead of false. And then we have the false in the one row that has NAs. Okay. And then in the very end, we've played around with this. I delete all of this. I close all of this, not delete. We played around with this data frame quite a lot. We have added a couple of columns that we calculated some stuff and like created some columns and we added them. And now we want to save our progress. And very conversely to the, where is it? It's down here. To the read CSV function, we also have a write CSV function, which you can use to write data frames into a CSV file. It has a very simple syntax. It's exactly the same as in read CSV, except that you have to specify which data you're writing, which is our table at Geo.Bonn. This entire file path we don't have to use because we have our working directory set to this folder here. So we can kind of get rid of this, except if you want to save it somewhere else that's not inside of your working directory. You give it a cool name. In our case, that's just, let's give it an English name. Mayor elections Bonn version 2. And then the file ending, and the separator is still comma because we didn't change anything in the formatting. And then we run this function. But for now, we're done with the script. I save it. And then why is this in the staging area? Did it do something with it? Let me check. Oh, okay, it created a CSV. It just gave a warning, apparently. Okay, yeah, but it worked. Interesting. Okay, it gave a warning message, but it executed the save and the file looks fine. So I will look over it soon and like check what's with the warning message. But yeah, it doesn't matter for now. We stage our stuff. And then we commit. And this is a terrible commit message. Solved all tasks. Okay. And now we push it. All right. And that's all our lecture tasks script done for today.